All right, here we go. It's Thursday, May 14th. 7 days from now, Algebra 2 will be over for you. Except for those of you that flunk and have to take it again.
Curse!
Oh, sir!
There's always summer school.
Ooh.
Okay, let me see here. Hopefully.
Summer school.
Oh, 6-5 quiz. Tell me where it is since I can't find it. Baird, Daniels, Daughtry, Griffin, Porterfield, and Valise. Where is your 6-5 quizzes?
Portercock, where is it?
Let's go, Portercock. Put it in right now.
Portercock?
Bruh, I turned it in.
Not in Dropbox. Where is it?
I'm pretty sure I emailed it to you.
Jaden.
I'll go back and check emails. You may listen up. All right, let's stop it. If you emailed it to me yesterday, particularly between about noon and 6 p.m., you may want to email it to us because the Microsoft Outlook had a meltdown yesterday. So if you emailed it to me in lieu of following the instructions and putting it in Dropbox, you may want to re-email it to me ASAP. Okay?
I'll do that.
I'll grade those over the weekend. And Mr. Valise, I'm sure you've checked the Blackbaud grade, right? And looked at the missing assignments lately. If you haven't, it might be wise to do so.
Yeah, I saw my grade. I'll fix it.
Valise.
Okay, here we go. All right, we are moving on to 6-6. Probably our last section that we get to. It's still, it's a good one we need to have for pre-cal and calculus. Still dealing with exponents and radicals, okay, and going back and forth and switching amongst the two. So it's more of the same, but just again a slightly different twist and a little more complex. So you may jot this down or make a mental note of it. I'm going to play about an 8 of a 10-minute video from Patrick JMT, who I think does a more logical, practical, your level explanation of things as opposed to Khan Academy. All right, it's Patrick JMT. So it's a good reference and resource to have. And the reason I like him is he explains it very methodically and clearly and concisely. And he just uses a big scratch pad and a Sharpie pen. He's left-handed and the camera's like over his right shoulder. So we'll run about 8 of the 10 minutes and then we're going to jump in. We're actually going to do, we're in section 6.6. I think I've already loaded it on Blackbaud. We're going to do problem set 1, which is only about 7 problems collectively in class. And we're going to start problem set 2, which is loaded on Blackbaud. And you're going to do that for homework. And I don't believe I put a Dropbox there because I've got quizzes to grade. And I got plenty of stuff to grade. I may have something for you on Tuesday that I'll grade, but this one doesn't have to be graded. But I would do it for practice so that if we quiz on this next Tuesday or next week, you are efficient. All right? Any questions, comments, or concerns before we start the movie? Get your popcorn and sodas ready.
Yes.
Questions or concerns? All right. So here we go. This is a good video. A great resource for you guys. So here we go.
That I want to remind you just kind of some basic rules where the exponents are actually whole numbers. So the first one says if you have like bases being multiplied, remember you add the exponents. So x squared times x cubed is x to the 5th. If you have things in parentheses, x squared cubed, you multiply the two numbers and get x to the 6th. If you have a negative exponent, you can write it as 1 over x to that positive exponent. Likewise, if this was in the denominator, you could put it in the numerator instead. If you have division, well, multiplication becomes addition. Division becomes subtraction. So x to the 10th over x squared is x to the 8th. And lastly, you can convert from a fractional exponent to a root with a power on it. With a root of a variable with a power on it, I should say. So it says if you have x raised to the fractional exponent of a divided by b, that's equivalent to having the bth root of x raised to the a. So let's do a few problems here, see if we can't make some sense out of that. So I'm out of my favorite non-lined paper, but what can you do? So let's evaluate 8 raised to the 2/3 power. Okay, there's a couple different ways you could do this one. The way I'm going to think about this is I'm going to actually rewrite this as 8 raised to the 1/3 quantity squared, because if I multiply 1/3 and 2, I do get my exponent of 2/3 right back. I can now use my property that says if you have a fractional exponent, it says the number that's on top goes underneath the root. The number on the bottom is the index of the root. So I could actually write this as the cube root of 8 to the 1st power, and that's still being squared. Well, the cube root of 8, that means I need a number so that if I multiply it by itself 3 times, I get 8. Well, 2 times 2 times 2 gives me 8, so the cube root of 8 is just 2. And I still have to square this, though. 2 squared is 4. So 8 to the 2/3 is just a fancy way of writing the number 4. So let's do some other ones here. Suppose I have negative 16 raised to the 3/4 power. Okay, so for negative 16 raised to the 3/4 power, one thing you want to be careful about is what this really says is negative. You should think about this as being in parentheses. The 16 is being raised to the 3/4 power. The negative is not. Again, I'm going to do the same thing as before. I'm going to write this as 16 raised to the 1/4 power, all cubed. My negative is still out front. Well, this time, if I'm raising it to the 1/4 power, that's like taking a 4th root of 16, and whatever number I get there, I'll cube it. So now I need a number times itself 4 times that gives me 16. Well, you can actually check that 2 works again, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So that cubed. Again, you do the cubing part first. So 2 cubed is 8. I'll tack on my negative and end up getting simply negative 8 as my solution. So suppose we have negative 9 raised to the 3/4 all squared. There's a couple different ways that you could do this problem. Now we have to be careful, because when things are being squared, you could think about the inside as being negative 1 times 9 raised to the 3/4 squared. And when you have things inside of parentheses being raised to a power, what that means is both of those things get raised to that power. So I could break this up as negative 1 squared and 9 to the 3/4 quantity squared. Well, negative 1 times negative 1 is just positive 1. I'm going to use this property that if things on the outside, if I have a power raised to a power on the outside, I can multiply. So I've got fractions, 3/4 times 2/1, that'll give me 6 divided by 4. So I've got 9 raised to the 6/4 power. Well, 1 is not going to affect the value, so I'm going to stop writing it. 6/4 reduces to 3/2. And now I'm going to use the same trick as before. I'm going to write this as 9 raised to the 1/2 raised to the 3rd power. Well, 9 to the 1/2 is the the square root of 9, all cubed. The square root of 9 is simply 3. I still have to cube that number, though. So 3 times 3 is 9, times another 3 will give us simply 27. Okay. Suppose, let's see, suppose we have, as another example, suppose we have 27 raised to the 5/6 power times 27 raised to the negative 1/6 power.
All right, I'm gonna stop it right there because we're not gonna do any of those kind of compound ones. So a couple things, and let me kind of share the next screen, and I'm gonna answer a couple questions. Let's see here.
Wait, sir, can you look what I like for the quiz? Do you want us to put the do you still want the answers in decimals to like the third decimal, or do you just want like the regular answer?
You talking about the quiz that was already due? The late
I
quiz?
guess.
Yes, this was already due.
Well, I mean, sir, I already and like you're saying that you don't have it, so I have to redo it again.
Actually, all your audio came in real broken up, so just stay after class and I'll answer that. All right, I don't want to spend class time dealing with that. All right, so let me go over a couple things that he talked about that make sense. This problem set, I don't believe I loaded it on Blackboard for today. So you just might want to have some handy paper there to scratch. We're going to scratch these out together. But what he was just talking about, one way to look at this is when we have fractions for exponents, what you might want to make a note of this just to keep it straight is the exponent or power is on the top. And just like on a tree, the roots are on the bottom. All right, so make sure you got that straight in your mind. Exponents or powers are on the top or the numerator of the fraction, and the denominator is the roots of that. All right. So, and he didn't really flat out say it, but when you saw him simplifying those things, when he simplified them, what did he do first? He did the roots first, not the exponents. What's that do for you? It keeps the numbers small. All right, if you did the opposite, and it would still work, if you did the opposite of that, you're going to get some humongous numbers. And when you start getting humongous numbers, then you're more likely to make a careless error. So address the roots first. So the thing is, this is kind of a new way of expressing this. This 28 to the 1/2 is just another way of expressing the square root of 28. Okay, that's all that was that he was talking about. All right, you've got two examples here to use as a reference or a resource. All right, so I'm not gonna repeat those for you. So get a piece of paper because I'm not going to load this up on Blackboard. So you're just going to make notes, and hopefully you wrote down that that formula that I wrote for you earlier. The powers or exponents are the numerator, and the roots are the denominator. So we're going to take baby steps here to kind of get used to this kind of new formatting of radicals and exponents, okay? So make sure you read the instructions, particularly if you would see this on a quiz. It says write each expression in radical form, or write each radical in an exponential form, all right? So if it's in exponential form, this is exponential, right? It's got an exponent of 1/7. It wants you to write it in radical form. So what's that mean? This is all you got to do. This is equivalent, these two formats are equivalent to each other. 11th to the 1/7 power is the same as the 7th root of 11. Does that make sense? Pretty straightforward, right? All right, so you do number 2. And while you're doing number 2, I'm going to wait 30 seconds, then I'll write it down. Do it just like we just did number 1. And you should have a piece of paper there in front of you, just like he had, and then just write it down. So it's 15 to the 1/3 power. All right. and put it in radical form. All right? And hopefully, hopefully you wrote it as this, the cube root of 15. Everybody good so far? All right, I'm going to jump down to number 4, and then I'll skip over to the second number 2, all right? So this one is in radical form, right? They want you to write it in exponential form. So it's the square root of 47, right? So the equivalent of that in exponential format is 47 to the 1/2 power, right? And remember, we set up here, the root is always the denominator of the fraction of an exponent, right? The root is always the denominator, all right? So, good so far? Questions? All right, so let's apply what he just did, right? So this is what, to put this now in radical format, it's the square root of 300 to the power of 3, right? Now, can we take this, can we simplify the square root of 300? Certainly. It's 3 times 100, right? And we love 100 because 100 is this 10 squared, right? So I can bring 10 squared out from underneath the radical, which is 10, leaving 3 under the radical, right? That's 3 out of 5. Okay. Don't forget, we still have the whole thing cubed, right? So now, let's see here. What are we going to do next? We want to cube everything, right? So 10 cubed, 10 times 10 is 100, right? 10 times 100 is 1,000. So now we've got 1,000, right? I just cubed the 10. 10 to the 3rd power, right? Now I've got to cube 3 under the radical, right? So that's 3. That's 3 to the 3rd power, which is 27, right? Well, 27 is the same as 9 times 3. Remember, this is to the 2nd power, right? Well, then that 9 can come out from underneath the radical. 9 can come out from underneath the radical, and I multiply it times 1,000. And now I've got the 1,000. The 1,000 I now have is 3,000. Because that 9 times 3 under the radical, the 9 came out as 3, and I multiplied times that 1,000 that was once there that I erased, and I still have a 3 under the radical. So that's this is our final answer. It's 3,000 square root of 3. Does that make sense? Kind of applying some of the same properties and principles that he just elaborated on. You can hear me, right? Oh, Bueller?
Yes, sir.
All right, got awful quiet.
So,
Got awful quiet. All right. Let's look at how we doing. We're doing all right. Let's look at number 5. All right. Why don't you take a look at this? Now we're gonna go from radical form to exponential form. Okay. Look at each one of these individually. Why don't you take a first guess at it? Just but treat each one, the 3, the a to the 5th, and the b squared individually. All right. Then rewrite it. I want you to take a first stab at it before I just write the answer out and kind of talk you through it. Just apply what we've talked about, what I talked about, and what he talked about these previous 20 minutes, and see what you come up with. All right, you're going to put it in exponential format. right? And a radical is going to no longer be there. Let's take a first stab at it. All right, so hopefully you came out with this. So, all right, so we got 3, you got the cube root of 3, which is now 3 to the 1/3 power, right? They get that part of it. And now we got a to the 5th power. We're taking the cube root of it. So it's a to the 5/3 power, right? And if you know that, then this one should be easy. And it's b to the 2/3 power. You see the 3 is the denominator in all 3 of those values there. Because why? Because it's the radical is always in the denominator portion of the fraction of the exponent. All right, are we ready?
So is that the final answer for that
I'm
one?
sorry?
Is that the final answer for number 5?
That's the final answer.
That's easy.
Does that make sense? All right, let's see here. Let's see if I want to do this next one. All right, at 162, I'm going to take a look at it and see if I can simplify, take something out from underneath the radical before I simplify it. So since it's an even number, I'm going to divide everything by 2. So and see where it takes me. See if I can get 4 2s out of it because it's the 4th root. So look what happens. I get 2 times 81, right? 81, if you got your little cheat sheet there, is 9 times 9, right? And we know from our vast exponential root experience, 9 is 3 times 3, right? So how many 3s do I got there? I got 4, right? Even though that looks like a backwards C. All right, so now I can do this before I do anything. I've got 3 radical to the 4th root, and what did I have left? I had a 2 still underneath there, and p to the 5th. Does that make sense so far?
Sure.
Can I do anything else? P to the 5th, that ring a bell? P to the 5th is p to the 4th times p, right? So why can't I do this? So now this becomes 3p and then 2 to the 4th power, right? Let's see. And since, I know this is kind of bizarro, right? This now becomes, since we're doing it in exponential format, we got 3p 2 to the 1 to the 1/4. That was a little complex. It's got a couple little twists and turns just because you can simplify that the p to the 5th and also the 162. So there's your final answer. It's 3 times p and then 2 to the 1/4 power. Fair enough? Questions? Make sense? What are y'all doing? Watching Springer or The View or what? Not paying attention to this?
I'm just confused.
So we're paying
All right.
attention.
All right, so if you're confused, ask me a question so I can unravel the confusion.
So like, are we dividing the exponents or what? Like,
No, because you can't, well, you can simplify the exponents, you can't divide the exponents. Remember in his video, and he's got several other videos there on his exponents and radicals. that you can watch. But no, we're really just simplifying. But more importantly, in these 8 or 9 problems, we're just taking radicals and writing them as a problem in a radical format, or we're writing an exponential format, or we're taking a problem in an exponential format and writing it in a radical format. We're just changing. If you're given one, you're putting it in the other.
Okay. But where'd you get the so do you take away the where do you get the 2 1/4 from?
All right, because let me do this, because we had that 162, okay, and then I was saying if we could simplify it, and I got 2 times 81. When I saw the 81 is 9 times 9, and each of those 9s is 3 times 3. Now remember, this is to the 4th root, right? This is to the 4th root, all right? So I've got 4 3s down here that can come out from underneath the radical as 3. That's where this 3 came from. That's where the 2 is still left under the radical. Okay. Actually, we're missing a p. There should be a p to the 1/4, aren't we? Thanks for the help, whoever's writing in the red. All right, that should be a p to the 1/4, because there was still 1 p left underneath the radical, right? Does that help, Mr. Belize?
Somewhat.
Somewhat. All right, let's try a couple more and see if I can clear up into some confusion. All right. All right. So let's rewrite this expression. All right. Now remember, this is the root, this is the exponent. So let's rewrite it. So we got negative 27, and we're taking the cube root of that. All right. And then we're squaring the whole thing. This is just another way to write what he had just did, or rewrite the original problem, right? And if you remember in the video, he always took the roots first. Again, that keeps the numbers smaller. You could do it the opposite direction, but it gets wild. All right, so we know, because we've used this number a multitude of times, 27 is the same as 3 times 3 times 3, right? And we know we're okay with this negative under the radical when I've got it is solvable when I've got a odd root, 3, and I mean odd as far as 3, 5, 7, 9, 11. If I had 2, 4, 6, 8, it'd be impossible unless we went back to that imaginary and complex numbers, which we're not doing here. So now I can now make this the cube root of negative 27 is negative 3. Agree? Cube root of negative 27 is negative 3. So the only thing I got left is now negative 3 squared, right? Negative 3 squared is a positive 9. And we're done. That's it. You're done. All right. Questions on that guy? That one should make sense. That's pretty straightforward. That should make sense. Okay. All right, so here we go. So what number 8 is asking you to do is we're doing the cube root of 216. All right, you know I know who's doing that, right? You may want to take your eraser and erase it, all right? You know this is being recorded, and you know administrative folks are watching these. So let's not be a total idiot. All right, so I'm taking the cube root of 216, right? Anybody have their little handy dandy sheet there of perfect squares and perfect cubes and exponential powers there? Or does anybody have a calculator and want to take the cube root of 216? Well, 216 is 6 cubed. So that is your answer. Cube, if I go 6 times 6 is 36, and then 36 times 6 is 216. Make sense? All right, this guy here. So we're taking the square root of 0.000, how many we got there? 3 zeros and a 4. All right, that's all we're doing. We're taking the square root of 4, let's say that's hundreds, thousands, 10,000, 100,000. The square root of 4 100,000ths, right? That's what we're doing. Okay, so we're taking the square root of that, and that I'd have to use my calculator. Some of you would too, because I probably mess up the decimal places. That is equal to 0.02. Hopefully you wrote all these down, because I don't have this posted on Blackboard. The next problem said I do. All right, questions. That's all of problem set number 1. Questions? All right. Anybody lost? All right, I'm going to stop share. Okay. I'm going to come up with, let's see. That's 1. Give me a second to enlarge this slightly. All right. So this is similar to some of the stuff he just did. All right. This one is posted on Blackboard. I don't believe I put a Dropbox on there since I've got plenty of stuff to grade over the weekend. All right. Remember, and if you haven't gotten ingrained in your head, make a note. All right. If I've got y to the something, remember the exponent is the numerator, and I've got an exponent in fractional format. The exponent or power is in the top. The root, like the roots of a tree, are on the bottom. That's how you can hopefully keep it straight. Okay? All right. So, let's see here. All right. So remember, so I've got identical bases. I've got identical bases, right? So I do what with those exponents? Anybody? You tell me, because I'm doing all the talking.
Don't you multiply that by the reciprocal? Or are you like,
If I'm multiplying identical bases, what do I do with the exponents? Multiplying is not correct. I do what? Remember, he did it at the very beginning of the video. If I've got identical bases that are being multiplied, I add the exponents. When you're multiplying, you add. You may want to write this down. When you're multiplying, you add. When you're dividing, you subtract, right? When you're multiplying, you add. When you're dividing, you subtract. So I love fractions. When I add and subtract them, I have to have common denominators, right? And this problem did it for you. So I've got x to the 10 over 5, right? 4 plus 6 is 10. And the common denominator just stays as the common denominator. And what he did next, if you recall, is I can now simplify that kind of compound exponent. And divided by 2 is, or 10 divided by 5 is 2. So that the actual answer for number 1 is x squared. Questions? All right. Now, hearing none. So now this is I kind of deem this that my exponents have exponents. And he talked about this briefly again at the beginning when he kind of did a quick review at the very beginning of the video. Okay, so my exponents have exponents. So how do I address that? We do what? He showed you. We multiply straight across. All right, so 2 times 3 is 6. 3 times 4 is 12. And just like we did in number 1, I got 6 over 12 simplifies to y over 1/2. So really, what are we doing? So with this being an answer, what are we really doing? What's another way to write or express that maybe makes more, in a more familiar format?
Distribute.
It's the same as the square root of y, right? This is the same as the square root of y. Are we good? Makes sense? Yes?
Oh, yeah.
All right. Any questions? I'm hoping the silence doesn't mean I'm lost. Okay, now I want you guys to try number 2. My second number 2. I don't know why that did it twice. All right. Do number 2. This second number 2, just like we did number 1. I'm going to let you do it first. You may have to do something before you do something. I know that doesn't make sense, but there may be an interim step that we didn't do in number 1. Are you trying it? Okay. Now we got identical bases that we're multiplying. So we do what with those exponents? Come on, guys.
Add them.
Participatory learning. We add them. And we add fractions, we have to have a common denominator. So 8 plus 7 is 15 over 10, right? Okay, yes, no, maybe so. All right, and that would then equal what? 15 over 10 can be simplified to p to the 3/2 power. Or another way you could write it, I'll take that answer there, the p to the 3/2. But really what you're being asked to do is take the square root of p, right? Because the root is on the bottom, cubed, right?
Yeah.
Questions? Okay, now I want you guys to do number 4, just like we did the 2 right above it. Do number 4. Tell me what you come up with. I'll get you started. There you go. You're welcome. That's a joke. Bueller. Nobody watch that movie, I guess. That's another Saturday detention for you. So what do we come up with? Anybody that's alive, has a pulse, is breathing.
Coronavirus.
I know Mr. Jackson's.
Jay, what you get?
I saw him getting ready for the next season.
Mr. G. Yes, sir.
All right. Hopefully you came up with this. 2 times 6 is 12. 5 times 5 is 25. So it's m to the 12th over 25. Questions, comments, concerns? Lost in the sauce? Makes sense? Doesn't make sense? I don't care. All right, so let's see, what do we got here? We got 15 problems on the back. We've already done the first 4. So you got 11 problems to do in the next 4 days. No, 5 days. Let's see, today's Thursday, Friday, Saturday, Sunday, Monday, I won't see you for 2 days or 5 days. So you got like, what, 10 problems to do in 5 days. You have to do 2 problems a day. All right? Do these for Tuesday, because we are going to go over these on Tuesday, and we may quiz or test on them at the end of the class that day. Okay? All right. Okay, we got 3 or 4 minutes left. What questions can I clear up? What questions can I clear up? I'm going to do a couple things, all right? Here's some clues. We're going to add number 5. We're going to subtract number 7. We're going to simplify number 9. I'm going to probably simplify number 11 by starting to see if I can get 5 2s out of 288. I don't know that I can, but I'm probably going to give it a try. But that'd be my first attack. I'm going to subtract these guys. Right? I'm going to multiply these guys. Let's see. What do I know about 10?
Say that again.
What do I know about 10? That's 7 squared, right?
Uh-huh.
So that can
Oh,
be
I see what you're saying.
as 7 to 2 over 4, right?
Right.
Can I do anything more with that guy?
Yeah.
So,
7 to
what
the half,
happened?
right? Square root of 7.
I told him. I'm so smart.
I mean, it seems like impossible to go from the 4th root of 49 to the square root of 7 is the same thing. But all right, so we're about out of time.
so how do we know to multiply number 6?
Number 6, because remember that's that situation where your exponents have exponents. So multiply those exponents, and then if you can simplify them, simplify. Remember, we've done some.
Yeah.
If
I
you
know
get
some.
confused, go to Patrick JMT and type in radicals and exponents or something like that. So he's got about 6 or 7 videos on this. I showed you the one that was kind of the most inclusive. All right. You knuckleheads that didn't submit the quiz, make sure you do that. I read the names earlier. I won't embarrass you for a second time. Make sure you do this. This problem set's already downloaded. It's already loaded up on Blackboard. Should be fine. If you can't print it out, I know some people had some problems with the last one because I forgot to put it in a PDF format, because sometimes in the Word format, the radicals or the exponents get boogered up. But this is already, I made sure I did it in the PDF so that hopefully it isn't, but if it is, email me and I'll send you the PDF version via email, and hopefully that'll resolve the problem. Last call for questions. All right. If not, you are free to go. Have
Sir,
a safe weekend, and we'll see you on Tuesday. Yes, sir.
Sir, my quiz, I have it right here, sir.
Oh, okay. Just give me a minute. I'll go get in the car and drive over and pick it up.
All right. That's 24. Sir, that's
I get it.
2406 Arrowwood Road, sir.
Okay.
I'll be
Don't
with
worry
you.
about your address. Yeah.
I just have a mask on and I'll come and then I'll put it on the front step and I'll come get it.
Tell Aubrey I said
Oh
what's
no,
up.
sir. I'll leave it on, sir. I'll leave it on the back door. The just come around the back. The back door will be open.
Why don't you give it to Brian and I'll just go to Kentucky Fried Chicken and maybe he'll give me a free bucket of chicken.
Sir, he actually doesn't work till later, so now I really kind of need this test to be turned in today. So,
Well, really, it'd be turned in just on time instead of late.
well, sir, really, sir. If we really want to go there, sir, I did turn it in, sir, on
Where-
time.
Well, my crystal ball is broken. Where is it hidden at?
Where is it hidden at, sir? It's not hidden. It's right. It's like,
Where did
boom.
you turn it in? It's not in the Dropbox as instructed. So where would you like me to go search for it?
My crib, sir. I have it right here.
Oh yeah, I forgot to swing by. I've only got 88 students' houses I got to swing by to pick it up.
Sir, just grade it right here, sir.
0.
0.
Done.
So, sir, do you want me to turn it in via Dropbox or the other one or
No,
email it to you?
I'm going to come over and pick it up. Remember? Don't you worry. Don't
All right,
you
I'm gonna just rip the
little
page
head.
off. I'm gonna tape the page to my door. You can just grab it off.
Okay.
Just grab it right off, sir.
And if it's there tomorrow morning, don't worry.
All right, bet. They say, see you, sir.
There you go.